Welcome to lesson 3 for unit 4. Today we'll talk about solving quadratic equations using the quadratic formula. So mine's on activity. Yesterday we looked at the most common method, factoring, for solving quadratic equations. I want you to pause the video right now, take some time to reflect. What steps did you take to solve quadratic equations using factoring? Once you do that, replay the video and then we'll do some examples. Okay, so I'm not going to give you the answer here. I want you to write it in your own words because that's you creating notes for yourself. But let's go through some of these examples. It says solve the following quadratic equations. The only method we know so far is factoring. So step 1, simplify both sides. There's really nothing we can do here. Step 2, bring everything over to one side. Here, we have an a value that's positive. We want to keep it like that, so we're going to move both of these over. So we have x squared. It's a positive 6x, so on the other side, negative 6x. And it's a negative 9 here, so on the other side, it would become a positive 9 equals 0. Once we have everything to one side, we factor. There's no greatest common factor, but I do see a trinomial. Again, I'm not going to show the steps here. I'm just going to go straight into the answer, because you should be comfortable with factoring at this point. I can rewrite this as x minus 3 squared is equal to 0. So now it's factored. And the last step, I set each factor to 0 and isolate for the desired variable. So this is the only factor I have. So I have x minus 3 is equal to 0. So x is equal to 3. So in this case, there's only one x value that I can put into this equation to replace all of the x's such that the left side equals the right side. Example B here, I have 3m squared minus m is equal to 2. Again, try to simplify both sides first. It's simplified. Now move everything to one side. So to bring the 2 over, it's a positive 2 over here. So on the other side, it will become a negative 2. Is equal to 0. Then I factor. There are no greatest common factors here, so I'm going to use trinomial factoring. Again, I did it in my head because you should be comfortable with factoring at this point. Now we have two factors equal to 0, so set each factor to 0. 3m plus 2 is equal to 0. To isolate, I bring the 2 over first. It becomes a negative 2. And then to isolate for the m, I'm going to divide both sides by 3. So I'm left with m is equal to negative 2 over 3. But I also have another factor here. M minus 1 is equal to 0. To isolate, I bring the negative 1 over, giving me m is equal to 1. So m is equal to negative 2 over 3, comma 1. So just to re-emphasize, sometimes when you're trying to solve these quadratic equations, if you can factor it, you might have one answer, or you might have two answers. Regardless of the number of answers you have, whatever your answers are, so in this case, negative 2 over 3 and 1, if I take the negative 2 over 3 and replace it with all the m's, or if I take the 1 and replace it with all of the m's, the left side will equal the right side in both cases. I want you to pause the video. I want you to try to solve this by factoring. So try to solve it and then come back in about once you think you have the answer. So pause the video now. Okay, so you should have tried and you should have realized that this equation cannot be factored. So not all equations, especially trinomials, can be factored. Here's a situation where it cannot. So what do you notice about C from above? Well, we notice that it cannot be factored. That doesn't mean that you cannot solve the quadratic equation. So what it mentions here is if you cannot factor a quadratic equation, you can still solve the quadratic equation using the quadratic formula. So there is an algorithm or an order in which you should approach these problems. So here it says solving quadratic equations, quadratic formula. When you are asked to solve a quadratic equation, always factor, and I'm going to put that in capitals because that should always be your first step. Always try factoring first. I'm going to just, okay, always try factoring first. If it can factor, that's great. Set each factor or brackets to 0, solve for the desired variable. Only and only if you cannot factor the quadratic equation should you use the quadratic formula. This is the quadratic formula. You should have it memorized. And so x is equal to minus b plus minus the square root of b squared minus 4ac divided by 2a. As it mentions here, before we can use the quadratic formula, you must recognize what a, b, and c means in the quadratic equation. Once all of the terms are brought to one side of the equation, a is always the number that is attached to x squared, b is always the number that's attached to x, and c is always the constant or the lone term. So taking a look here, what would the a value be? Well, whatever is attached to the x squared, which is not 2, but negative 2. So don't forget the signs. The b value is whatever is attached to the x. Here it's 3 or positive 3. And the c value is the constant term, which is negative 5. So again, don't forget the sign. So once you have an equation, you'll have the a, the b, and the c values. You will plug those into the correct spots. And this x ultimately represents the x value that you are solving for. Solving for. So we'll see an example of how to do that. So before we actually get to the quadratic formulas, I want to practice finding the a, the b, and the c value. So let's take a look at this. Remember, before you can find the a, b, and c values, everything must be brought to one side. So you should be in the form something is equal to 0. Once everything's brought to one side, again, the a is what's attached to the x squared, so it's 2. The b is what's attached to the x. In this case, there's no number there, but remember that just means that there is an imaginary 1. And because there's a negative up front, it's negative 1. And the c value here is the constant term, which is positive 4. Taking a look at this, I can't read my a, b, and c values yet because everything has not been brought to one side. So do that first and try to keep your a positive, as I've already mentioned, because that makes factoring easier. So the a is positive here. We're going to keep this on this side, bring everything else over. So 7x squared, when I have a negative 2x and I bring it over, it's positive 2x. When I have a positive 3 and bring it over, it's negative 3, which equals to 0. And now I can name my a, b, and c. So a is 7, b is 2, and c is negative 3. Pause the video, try this one yourself, and then see if you got it right. Okay, so here, again, you need to bring everything to one side. So 4x squared minus 13 is equal to 0. The a here is the number attached to x squared, which is 4. The b, I don't have an x, so there's nothing attached to the x, so the b is 0. And the c is the constant term, negative 13. So you need to be able to identify these before you can put them into the quadratic formula. So let's see an example of where we use the quadratic formula. So steps, quadratic formula. Simplify both sides of the equation as much as possible. Bring all terms to one side of the equation of the equal sign. The other side must be 0. So what you should notice is that these two steps are the exact same first two steps of solving quadratic equations using factoring. Then you try to factor. If it factors, great, use those steps. If it doesn't factor, then you need to determine the A, B, and C values, and plug the A, B, and C values into the formula. So solve the following quadratic equations using the quadratic formula. Provide both exact solutions and solutions rounded to 3 decimal places. Now for these questions, I'm specifically telling you that they don't factor, so you must use the quadratic formula. If this question just said to solve the quadratic equation, you have to start with factoring first and then try the quadratic formula if it can't be factored. But these ones, I'm telling you, cannot be factored. So we have this. Again, the first step is to simplify both sides of the equation as much as possible. I can't collect like terms here or here, so I'm good. Bring all the terms to one side of the equal sign. That's been done for me. Great. The other side is a 0. Determine the A, the B, and the C values. Here, the A value, the number in front of the x squared, is 1. B, the number attached to the x, is -5. And my C value is -8. Once I have these values, all I have to do is copy down my quadratic formula and plug these numbers in. So x is equal to minus b plus minus square root b squared minus 4ac over 2a. So we'll start by plugging in everything we know. We know we're trying to solve for the x, so keep that as is. There's a negative here, I'm going to copy it down. The b is -5, so replace it with -5. Plus minus square root, I have another b, so replace it with -5 in brackets, squared, minus 4. I have an a, which is 1, c, which is -8, divided by 2, 1. Now this looks like a whole bunch of math. What I suggest you do is do stuff on the side and specifically start with the numbers underneath the square root. So I'm going to do it off to the side here. So I'm just going to copy this down. -5 squared minus 4, 1, -8. So I have an exponent here. -5 squared is, remember, -5 times -5, which is positive 25. And then I have -4 times 1, which is -4, times -8, which is positive 32. And 25 plus 32 is equal to 57. So always start with the values underneath the square root first. So if I was to simplify this, I have x is equal to, I have a minus and a minus, so that's going to be a +5. I copy down the plus minus, and now I have square root. I said this entire thing is the same thing as 57. So 57 divided by 2 times 1, which is 2. So now it seems more manageable. So underneath the square root is where you're going to have the most expensive amounts of math to do. So do those off to the side and then fill in your answer. We saw this symbol yesterday, the plus and minus. This essentially means we need to take both the plus version, so plus root 57, and the minus version, so minus root 57. So at this point, we are going to split it up. So we're going to say x1, or our first x value, is going to be 5 plus the positive version of root 57 divided by 2. And x2 is going to be 5 minus root 57 divided by 2. So because we have to take the plus and minus version, we're just splitting it, where one version we take the plus root 57, and the second version we take the minus root 57. We say that these are exact solutions. Why are they exact solutions? Because we didn't have to round anywhere. We don't know what root 57 is. It's a nasty number with a lot of decimal places, but we didn't have to round any of those decimal places. We're giving root 57 as is. So when it says provide both the exact solutions, that just means leave the answer as is, as long as the square root is simplified, and we'll talk about that in later. Or you need to have your solutions rounded to 3 decimal places. In order to do that, you need to put these into your calculator. So give me 1 second. Okay, so I'm going to plug this into my calculator. So the first thing I have to plug in is 5 plus root 57 divided by 2. What I need you to do is plug in the top in brackets and plug in the bottom in brackets. So it's going to be open your bracket, 5 plus, you should all have a root sign, root 57, close the brackets, that's the entire top, divided by the entire bottom in brackets, which gives me about 6.2749. And the question said to round it to about round it to 3 decimal places. So we're going to say this is the same thing as about. So when you put a dot on top, it means about or approximately 6.275. The 4 was rounded up because of the 9 beside it. Then to put in the second scenario, again, open your brackets, 5 minus root 57. So that's the top, divided by 2, and that gives us approximately negative 1.275. So this ultimately tells us that this equation has 2 solutions. One is about 6.275, one is about negative 1.275. But if we wanted the exact values of the x, the first x value is 5 plus root 57 over 2, and the second one is 5 minus root 57 over 2. Sorry, that was my phone. So now we're going to move on to our second example. It looks weird because in the previous examples with factoring, we got nice numbers like x is 3 or x is 5. And we said if we take those answers and put them into this equation, the left side will equal the right side. Well, the same thing happens here. If I take this and plug it into all of these x's, the left side will equal the right side. Or if I take this and plug it into all my x's, the left side will equal the right side. So let's move on to our second example here. So we'll start with the first rule. It says simplify both sides. If I take a look, it's simplified as much as it can be, so that's good. Next, we're going to bring all terms to one side of the equal sign. Again, we want to try to keep our a positive, so let's bring these over to the left. So I'm going to copy down the 2x squared. The plus 3x would be a minus 3x on this side. The plus 5 will be a minus 5 on this side, which equals 0. The next step, I want to try to factor, but remember these questions I specifically said they aren't factorable. So because they aren't factorable, let's move on to the quadratic formula. So to use the quadratic formula, again, I need to know my a, b, and c values. My a value here is a 2. My b value here is a negative 3. And my c value is a negative 5. So because I have these, I can now go straight to putting them into my quadratic formula. So write out the formula. X is equal to minus b plus minus b squared minus 4ac divided by 2a. Once you write it out, plug in all the values that you have. So x is equal to, there's a minus there, and b is negative 3, so I'm going to put that in brackets, plus minus the square root sign. The b here is a negative 3, so negative 3 squared minus 4. My a is a 2, and my c is a negative 5. You'll notice I keep extending the square root. That's because you need to make sure that all the values are underneath this square root sign. And all of this is divided by 2 times a, which is 2. As I mentioned before, it's really the values underneath the square root sign that are more complicated or more that require more math. So do that off to the side. And I'm going to do it right here. So we have negative 3 squared minus 4 times 2 times negative 5. So again, negative 3 squared is 9. And then here we have negative 4 times 2, which is negative 8, negative 8 times negative 5, which is positive 40, and so that gives me 49. So now I can replace that. So I have negative and negative 3, which is just positive 3, plus minus. I know everything underneath the square root gives me 49 divided by 2 times 2, which is just 4. Now I can keep going, and in this case, it's actually a nice number. So it looks like I did lie to you. This is an example of something that can be factored, but we are still going to use the quadratic formula to do it. In future evaluations, you should be factoring first and seeing if that works first. So let's simplify this. I can say this is the same thing as x is equal to 3 plus or minus. The square root of 49 is 7 divided by 4. So again, I have two scenarios, a scenario where I take the positive 7 and a scenario where I take the negative 7. So we're going to do both scenarios. The first scenario is where I take the positive 7, so 3 plus 7 divided by 4. And the second scenario is where I take the negative 7, so 3 minus 7 divided by 4. If I put this in, I have 3 plus 7, which is 10 over 4, which can be reduced to 5 over 2. And here I have x2 is equal to negative 4 over 4. So x2 is equal to negative 1. So ultimately, my two solutions here are 5 over 2 and negative 1. So x is equal to 5 over 2 and negative 1. Again, this was my mistake for putting this question. Yes, you can still solve it using the quadratic formula, but if you can factor, do that first because that will help save a lot of time. Let's do one last example. So I'll show you how to do this one as well. Okay, so again, we want to bring everything to one side, simplify it. Everything's been done for us here, so it's nice. Let's assume again that this can't be factored, and I'm looking at my notes and it cannot be factored this time. So you want to choose an A, a B, and a C value. So the A value here, or not choose, but determine. The A value here is a 5, the B value here is a 3, and the C value here is a negative 5. I see that it's kind of blurry. Let me just try to see if I can get it a bit sharper. So that's a bit better. Okay, so 5, 3, and negative 5. So now I'm going to plug it into my quadratic formula. So x is equal to minus b plus minus b squared minus 4ac divided by 2a. So I copied the negative. The b this time is a positive 3. Plus minus, again, I have the b value, which is a positive 3 squared minus 4. The a is a 5. And the c is a negative 5 all over 2 times a, which is 5. Again, it's the part underneath the square root that tends to be the most complicated or has the most steps. So let's do that off to the side. We have 3 squared minus 4, 5, negative 5. So 3 squared is just 9. Negative 4 times 5 is negative 20. Negative 20 times negative 5 is positive 100, which is equal to 109. So I keep going. Now I can simplify this. A minus times a positive 3 is just negative 3, plus minus. I put the square root, and if I already figured out this value, it's 109. Divided by 2 times 5, which is 10. So again, I have two scenarios, the positive and the negative, so I'm going to break it down. So x1 is the positive scenario, so negative 3 plus root 109, negative 3 plus root 109 divided by 10. And x2, which is negative 3 minus root 109 divided by 10. Again, these are the exact solutions. If I want to approximate them to 3 decimal places, then what I need to do is I need to plug this into my calculator. I'm just going to do it very quickly. And then make sure you try putting into your calculator and you get the same answer. So this is negative 1.344 approximately. And this is about sorry, I messed up. This is negative 1.344 approximately. And this up here is negative 3 plus root 109 divided by 10 is 0.744. Okay, so you should be able to get those values in your calculator. There's one last thing I want to do before we end off today's video. Okay, so I just want to create a flow chart with you on how you solve quadratic equations. So if you have an equation, if you have a question that says solve this quadratic equation, the first step is to always rewrite quadratic equation as 0 is equal to ax squared plus bx plus c. So you're always bringing everything to one side, simplifying it as much as possible. The question you want to ask yourself is, can I factor the equation? So that's always, remember, the first thing you're always going to try factoring it. If your answer is yes, then you want to factor and solve for x variables. If your answer to that question is no, then you want to solve x values using quadratic formula. So whenever you have a solving question, again, you always try to factor and then solve. If factoring is impossible, that's the only time you go to the quadratic formula. So I want you to try this on your own. So it says solve the following quadratic equations. Remember to check if you can factor first before using the quadratic formula. So go through these 3 questions. If you can factor, then solve. If you cannot factor, then put in your ABC values and solve using the quadratic formula. Here, I've set it up nicely to remind you. So you ask yourself, can I factor this equation? You press yes, or you circle yes or no. And if it's yes, factor, solve. No, then write your ABCs and do the quadratic formula. But on future evaluations, I will not give this to you. You need to automatically know to always check factoring first. So I want you to do these questions, take a picture, send them to me, and then your homework is handout B, page 222, number 1235. Thank you.